Good day guys, being here. Yesterday we modeled this railing family. Okay, yesterday, and today we're going to try a different method. We're going to use adaptive family. Okay, so let's do it. So first, create a generic model, adaptive, and place 2 points. Make them adaptive. Create a spline, check this reference line. Okay, select the point again, draw on work plane, set work plane, pick the horizontal work plane, place it on point 1, and set work plane, pick the horizontal work plane of this point 2 and place it on point 2. So select these 2 points, and here offset, let me just type in 1 meter. So see, this will be the height. Let's create a height parameter, and I'll just move this closer to 0.1. Okay, so now select these 2 points, create a spline, check the reference line. So now we have 2 reference lines. Select these 2 reference lines, create a form. Select the one on the right, and this will be the a face. We're going to use this to create the grids to place adaptive families. Okay, so select this face, divided surface, and here U grid, change it to 2, and for V grid, change it to fixed distance. Okay, so let's try 200, and you will see these are 200, but we will have half grid, half panel here. So change this to beginning, so it will start from here. So this will be exactly 200. If you will see the last panel will be smaller, so that's okay. And also I'll just quickly explain to you. So if you change to maximum spacing, all the grids will be always equal, but they are going to be slightly smaller than 200. Sometimes it can be 200, but yeah, if you change this, they will become smaller. Okay, so let's change this back to fixed distance. Okay, so always start from here, 200, and what left is on this side. Okay, so now select this divided surface, and here turn on the nodes. Okay, so now these nodes, we can use these nodes to place adaptive family. So now I'm going to quickly do a screenshot to explain what we're going to do. So next we're going to create a family, adaptive family, look like this. And then we're going to place one here, and we're going to place another one here. And then we'll select both of them and use this repeat tool. So it will repeat itself if this face is the size of the face or the number of the grids are increased. It will always automatically repeat itself. And also we're going to place another one here, another one here, and also do the repeat. Okay, so it will continue. Okay, so now let's create that family. So new family, it'll be generic model adaptive. So in this family, we're going to place 3 points. Okay, so select all of them, make adaptive, and then select each 2 of them and create a spline and reference line, spline, reference line. So now we have this triangular shape. Okay, so now what we need to do is, I'll do another screenshot. So this will be, eventually the shape will look like this. Okay, it would be it will be 2 straight line, so 1, 2 straight line, and then with an arc, so arc. So to be able to do this, we need a few points. So first, the center of this arc, we need to define this one, and also we need to find this point as well as this point. Okay, so for this point, so what we need to do, because we know that from the distance from 1 to 2, let's call it A, let's call this B, C. In this triangular shape, we know A, B, C. We can use a reporting parameter to get A and B and C, and then we can work out this angle. Okay, so if this angle is capital C, C equals arc cosine bracket A square plus B square minus C square divided by 2 times A times B. Okay, so this is angle C. So once we know what the angle C is, and also because this point will always sitting on this line, so this is a line that equally divide this angle C. Okay, so which means once we know the angle C is, we know half of the angle C is, and then in this triangular shape, in this one, if I connect from this center to here, this will always be 90 degrees. Okay, and then we know half angle C. We know the radius, and then we can work out this distance. Okay, once we work out this distance, we can work out where this point is, and we can also work out this length of from point 2 to the center point, and from this we can work out where this center point is sitting on this line. Okay, so this will be exactly the same to that one. Okay, so let's do it. So first we need to create a 3 reporting parameter. So before we add a dimension, just use set work plane and pick the work plane of this reference line, and di dimension, make sure you pick the point. Okay, so this is dimension 1. Set work plane, pick this reference line di, and set work plane, pick this reference line di dimension. So now let me just change the scale a little bit. Okay, so select this dimension and create, let's call it A, instance reporting, and OK. And this one, create a new B, instance reporting. Select this one, create a new parameter, let's call it C, instance reporting. And okay, so let's have a look at this image. So now we can get this one from this formula. So let's go family types. We're going to create an angle C. Change this type to angle and instance, and OK. So under this formula, we're going to use the formula. So arc cosine ACOS. So bracket A, another bracket A square plus B square minus C square bracket divided by bracket 2 times A times B bracket, another bracket. So now we get 66.45. We can check the angle, see if it is correct or not. So go create an angular parameter dimension. Yes, 66.45. Okay, so the next step, we need to find the line that equally divide this angle. Okay, so I know that if I place a point on this line, and oh, sorry, wrong one. So you will see that it shouldn't be this big. We need to use place on face. Okay, you can tell from the size. If you use place on face on the line, the point will be very small. Okay, so if I place a point here, and I'll change this to segment length, and I'll just have a look. See, okay, so the dimension is from here to here. So now I'm going to change it to end, which means this dimension is from this point to the point 2. So if I place a point here, and if I place another point drawn face on this line, I'll change to segment length. If the distance from this point to the point 2 are the same, so for example, I'll just type in 2 meter, for example. If the distance are the same, and then if I select them, create a spline and make a reference line. So then if I connect them and place a point on the center point, on the midpoint of this reference line, and then select these two and create a spline. So if these two so this length and this length are the same, and then the middle point, if I connect this point to this point, these two angles will be the same. Okay, so we can do a dimension here. Oops, sorry. Set work plane first. Okay, so di, oops, angular. So you will see these two angles are the same. So we just need to make sure these two, so the segment length of these 2 points are always the same. Okay. In this exercise, I also want to make this line as long as possible. So probably here, and then make sure the center of the arc will be sitting on that. So if the line is only this short, you won't be able to place a point on this line. Okay, so if you have an arc like this. So what I'm going to do is I'll use a formula to find the smaller number between this A and B, and I'll equal the segment length of these 2 points to whichever is smaller. Okay, so let's go to family types. So I'm going to create a new parameter. Let's call it a D instance. Okay, so the D equals, I'll use if condition. So if A bigger than B, if A is bigger than B, and then I'll use B. Otherwise, I'll use A. So bracket. So this is the formula. So now you will see the D equals 11 meter, which is A. This one smaller. Okay, so now select these 2 points. Segment length just equal to D. So now you will see these 2 points. One will sit on the point 1 exactly, and then this point will match the length of A. Okay, so let's try. So if I increase this, it won't change, but if I reduce the B, so you will see now the segment length equals B, because B is smaller. Okay, so now we can always have these lines relatively long enough for our arc. Okay, so now I'm going to create the radius parameter. So this parameter, so we can use this parameter we can adjust this parameter ourselves. So it will be a r length instance parameter. So I'm just going to type in, for example, 100. Okay, so Actually, I know the scale of this. Maybe I'll just reduce the scale of this. So 100 is relatively big enough. Okay. So still maybe like this. Okay, right, roughly 1 meter. So 100 will be something like this. So now we need to do what we need to do. I'll just do another screenshot here. So let's say a radius will be, so if I place a point here, and if I connect perpendicular to this one, perpendicular to this one, this will be the R. Okay, so this will be the radius, and then this will be the arc. So now from here, so we know this is C divided by 2, half of the angle C, and this I'll just make this bigger. Okay, so this will be something like this, right? 90 degrees. So this is 90 degrees. So this is R, and this is C divided by 2. So we know this 2 and this 90 degree. So now we can work out. So I'll call this, let's call this E, and call this F. Okay. So E equals R divided by tangent C divided by 2, R half C, and F equals R divided by sine half C. Okay, so now let's do this E and F. So create a new parameter. Let's call it E instance. Okay, another F instance. Okay, so E equals R divided by bracket, which one? Tangent, T-A-N. Oh, sorry, the bracket need to go. C divided by 2 bracket. Okay, so and F equals R divided by sine C divided by 2 bracket. Okay, so apply. Okay, so now we can place this. We can place this point and this point. So let's place this one first. So this one will be offset. So will be a point on this reference line, but offset from this point by A. So I'll place one point, draw on face, place it on this reference line, and select this point and change this to segment length. And I just need to work out. Okay, so this is the distance from here to here. So I'll change this to end. Now we can link this to E. Okay, we found this one, and another one. Draw on face, place it on this one, the same. So 0.1, which is closer to this one. Good. And segment length link to E as well. Okay, so now let's find the point, this one, which is offset from this point by F. So draw on face, place it here. So let's have a look at first. It's 0.3 closer to this, which is correct. Change it to segment length and link it to F. Okay. So now we know that the arc, the circle, the center of this arc will be here. So now we just need to draw the arc. Okay, so now first reference a circle, draw on work plane, set work plane. Pick the horizontal work plane of this point and draw a circle. and create a radius parameter and link this to R, and you will see it will go through these 2 points. Okay, so now actually let me just create this reference line. So one on here and the other one here. So select this one and point 3. And okay, so now we can just create an arc here. So go reference, start and radius arc, draw on face, 3D snapping. So point 1, 2, and pick this point, quadrant. Okay, so and escape. So now this is 1, 2, 3 reference line. And so let's have a test. So all good? Yes, all good. So now we can create that a sweep. So I'm going to place one point, draw on face, and place it anywhere on these one of the 3 reference lines. So I'll place it here. So for example, reference circle, draw on work plane, set work plane, pick the vertical work plane of this point and create a shape, a profile. I'll make it 20 radius, and then select this profile together with these 3 reference lines. Okay, 1, 2, and 3, and create form. So this is it. So let's try to adjust this point. All good. Adjust point 3. Good. And even let's lift this point. Still good. Okay. So now we can load this into here and place this on this all these grids, all these nodes. So place 1, 2, and 3. 1, 2. Oh, sorry, wrong one. I need to place it here. So go create component 1 and 2 and 3. Now if I drag this point 2 to make it longer, and then select these 2 adaptive family and click on repeat. And also you can change the grids. So for example, I'll change to 100. Looks like that's too small. I think that's too small because relative to the radius. We probably need to adjust the radius. Where's the radius? It's an instance parameter. So maybe it's good to edit the family. Then let's change it to, instead of instance, we'll use type parameter. So it's easier for the repeater. So you can click on this, edit type. You can adjust the type parameter. Okay, so for example, I'll change it to 50, maybe 30. Okay, so it's quite small. Now maybe it's okay to change this to 100. Yes. Okay, so let's try. Oops, sorry. Let's come on. Let me rotate you. Okay, go create component. Let's place another 1, 2, and 3. 1 and 2 and 3. Select these 2 and repeat. So now you will see it will go repeat itself. So this will be it. So if you can drag the point 2, depending on how long it is, it will repeat itself. Okay, and I think that's it. This is the main idea. You can, of course, you can adjust the height to somehow to match the level of 1 and 2. So when you place it will automatically go, but that I will leave it to you. And also, of course, you can add another member on the top. like that. Okay, so that's it for today. I'll also upload this family for you so you can have a look, have a play yourself. Okay, so thank you. I'll see you next time. Bye.